Hello students, welcome back. Nice to see you. So, let us start with the next module of the chapter, rotational motion, called as moment of inertia of a ring. Now students, last module also we discussed moment of inertia of a ring. So in this module, again we are going to discuss moment of inertia of a ring. So what's the difference? Here, axis of rotation is different. Is that clear? Fine. So, you geared up? Yes, I see that. Can I move on to the module? Fine. Let us start the module. First, we need to find out the moment of inertia of a thin ring about the tangent to its plane and parallel to the diameter of the ring. Alright. Now, I can understand. Bit difficult. Let us bring in the diagram. Diagrams will make things simple. So I'll take a thin ring. Point C is the center of the ring. M is the mass of the ring. Alright. Now, go on to the title. Moment of inertia of a thin ring about the tangent to its plane. So I have to draw a tangent. So let me take point O on the circumference of the ring and let me draw a tangent through point O. So y dash is the tangent through point O and this tangent is in the plane of the ring. Is that clear? Fine. Next. This tangent is parallel to the diameter of the ring. See the title. Now, I will draw one more axis. Now, this axis is passing through the diameter of the ring. This x dash is passing through the diameter of the ring. Now, see your students. Y dash and x dash both are parallel to each other. Is that clear? Fine. Now, let me draw one more axis. Now, this axis, z dash, is passing through the center of the ring and it is perpendicular to the plane of the ring. Is that clear? Fine. Now, if this ring rotates about the axis y dash, its moment of inertia is I naught. If this ring rotates about the axis x dash, then its moment of inertia is id. Now students, what we need to calculate? See the title. Moment of inertia of a ring about the tangent to its plane. So here, y dash is a tangent, so we need to find out I naught. So, diagram is on your screen. What is I? How will you calculate I? Tell me. Yes, see there. Two parallel axes. So which theorem? Very good. We can use parallel axis theorem. According to parallel axis theorem, I naught is IC plus MH square. Now hold on. What is H? H is the distance between the two parallel axes. See the diagram. Can you guess what will be H? Yes. Yeah. You said the answer. Very good. H is equal to R. It is the radius of the ring. Yes or no? So we have H. And we know IC is equal to ID. Can we calculate I naught? Yes. So, I naught is equal to what is IC? IC is equal to ID. And what is the formula for ID? Last module. It's very important. We discussed what is ID? Yes. Very good. So, you have revised. ID is nothing but it is half mr square. So, then instead of IC is equal to ID. So, I will write half mr square. Now, plus mh square. We need to find out what is h. And we all know h is equal to r, so h square will become r square, so I naught will be half mr square plus mr square. Now students, you can add it. You will get I naught is half mr square plus mr square is what? Yes, it is 3 by 2 mr square. Now students, here y dash is your tangent. So then we can say I naught is equal to it. It, the t is just to specify it is a tangent, just to mention it. Is that clear? So, I naught can be written as IT. So, IT is equal to 3 by 2 mr square. Very simple derivation. Here the tangent is in the plane and it is parallel to the diameter. Is that clear? Which theorem? Parallel axis. Any doubts? No? Fine. Let us move on to the next one. Here we need to find out the moment of inertia of a thin ring about a tangent perpendicular to its plane. So here again tangent, but this tangent is perpendicular to the plane of the ring. So, can you guess the diagram? Yes? Fine. First, I will take a thin ring. Alright, C is the center of the ring and M is the mass of the ring. Here, I'm going to take R as the radius of this ring. Alright, first, let me consider an axis. This axis is passing through the center of the ring and perpendicular to the plane of the ring. Which axis? Z dash. Now, if this thin ring rotates about the axis z dash, then its moment of inertia is IC. Is that clear? Now, look at the title. Tangent perpendicular to its plane. So, I have to draw a tangent. For that, let me take point O on the circumference of the ring and let me draw a tangent through point O. But this time, the tangent is perpendicular to the plane of the ring. So, here x dash is our tangent. Now, if this ring rotates about the tangent, then its moment of inertia is I naught. Now students, what we need to find out? We need to find out I naught. Again, which theorem? Two parallel axes. Which theorem? Very good. We can use parallel axis theorem. So according to parallel axis theorem, I naught is IC plus Mn square. So we can write I naught is equal to IC plus, hold on, what is H? H is the distance between the two parallel axes. See the diagram. Can you guess what will be H? Yes, H is equal to R. So H square will become R square. So I naught will be IC plus MR square. Now hold on, what is IC? IC is the moment of inertia of a ring about an axis passing through its center and perpendicular to the plane. This we have discussed in the last module. What is IC? Yes, I heard you. IC is MR square. So I naught will be IC, which is MR square, plus MR square, which is nothing but 2MR square. Now students, x dash is a tangent. So again we can say I naught is equal to IT. So IT is 2MR square. Again students, very, very simple derivation. Parallel axis theorem. Here the tangent is perpendicular to the plane. Any doubts students? Again it's a simple module. The first case tangent was in the plane. Here tangent is perpendicular to the plane. So I'll meet you up in the next module. Until then, keep working. Nobody can stop you. Take care.